All right there, ladies and gentlemen. We're actually on the same page as we were before. It's going to be the proof at the bottom of the white page. Again, it's presented as bonus, but let's be honest, it wasn't bonus. I mean, that's something we covered in class. I expect you guys to know how to do it. So prove the product of any two odd numbers will be odd. Now, no, you can't do an exhaustive list for this. There's too many examples. Um, I mean, even if we just pick an example like 3 times 5 equals 15, yeah, that doesn't actually prove the case. I mean, it serves as an example of the case, but not exactly it. But it kind of can give us a roadmap about what to do. I mean, what we really have to do to prove this is a general calculation. If we can somehow show or move this from being just a regular 3 to something that represents any odd number at the same time, and same thing like with this 5, this slot, if we can rewrite it so it represents every odd number at the same time, then we're in business. I mean, we already know how to do this one. We kind of agreed a long time ago that if I want an odd number, that's the same thing as taking 2 times an integer plus 1. Because 2 times an integer would, of course, be an even number. One more than that would be an odd. What we have to show is that this calculation is the same as 2 times an integer plus 1. So, of course, well, how do we do that? Well, I mean, if we just take 2 times any integer and add 1 to it, it's an odd number. So if I just choose a different variable, so like 2 times m plus 1, well, that in itself would represent an odd number. It has to. If I choose any m, let me move this around a little bit. If I choose any m, as long as I make the caveat, or maybe I can call it a given, where I just simply let m be an integer, then this is going to result in an odd number. Likewise, if I choose a different variable, say n, say 2n plus 1, and again let n be an integer, then of course 2I plus 1 is odd. If we accept those three facts, where m and n are integers, 2I plus 1, I being integer, is odd, then all we have to do is run this calculation and show this like this. I mean, in the end, if we're just confirming this calculation is the case, um, then I'm just trying to confirm that equality is actually true. Well, guys, this is just a binomial times a binomial. That is going to be a form of well, a form of double distribution. In other words, just multiply the things together. So take this 2m and multiply by everything in the second parentheses. So 2m times 2n would be 4mn. 2m times 1 will be plus 2m. 1 times 2n would be 2n. And then 1 times 1, of course, is going to be 1. And we're still trying to show that that's the same as 2 times any given integer plus 1, hence odd. We have to make this side look like this side. Well, we can do that. We have to be sneaky with our algebra. We can totally do that. I mean, when I say it has to look the same, that's what I literally mean. I need 2 times something here in parentheses plus 1 at the end. Well, look, I already got the plus 1. I just have to make this part look like 2 times something in parentheses. But hey, looky here. I have 3 even numbers right here. I can factor that out. I can factor out a common 2 out of 4mn and leave it just with 2mn. I can factor out a common 2 out of 2m, leaving it just with m, and factor out the 2 out of the 2n, leaving it just with n. I think our proof is done. Let me explain why. Uh, the 2, the 2 is in place on both sides. The plus 1 is on place on both sides. Well, look at that highlighter. What is going on there? Pen, highlighter. Let's go bigger. So the plus 1 is in place on both sides. The 2 is in place on both sides. Well, look at this part in the middle. I need it to be an integer. Well, if m and n are all integers, and so is 2, then this entire thing will result in an integer. So this is 2 times an integer plus 1 is the same as 2 times an integer plus 1. Guys, that's a good proof. We're done. That's it. We have shown that if I take any two random odd numbers and multiply them, the result will be 2 times an integer plus 1, hence odd. That is complete. That is finished. We are done.